Hello, I'm Imagine Thakur and I'm going to give a presentation for Big Data Analysis and Project, and my topic name is House Price Prediction. So let's go to the contents. Introduction, implementation, conclusion and reference. This is what I'm going to talk about. So introduction. So whenever you go to buy a home, you actually look for the number of rooms, the garage, the car parking, and so on. But you neglect the features like the fencing height, the distance between the roof and the wall ceiling. So and many much more. So to help to and put together all the features and predict the perfect sales price, machine learning comes into the picture. We have taken this data set from the Kaggle website, and the data set has 1460 and 8 rows and 81 columns. We have done data processing, data cleaning, data visualization, outlier detection, algorithm to train the data, metrics to predict whether this algorithm stands or not. So we have done many things. Before that, I'll give an overview. The ID which we're using is Anaconda Jupyter Notebook. Language we are encoding is Python. Algorithms we are using is linear regression and random forest. Libraries which we are using is NumPy, Matplotlib, Seaborn, Pandas, SciPy, and scikit-learn. The statistical metrics which we are using is root mean square error, mean square error, mean absolute error, and to test the accuracy we are using R2 score. So let's get into more details. So data processing. The first step is data processing. So in the data processing, you can see that the data over here has many null values and missing values. So we have to treat these missing values. Missing values can be of two types. One is numerical and one is alphabetical. So to treat for alphabetical, you have to fill it with nan values. To treat numerical, you have to fill with zeros. Even though your accuracy don't boost up, then you have to drop some of the columns which has more null values, like for example, pool, QC, miss, feature, alley, fence, file, QU has more null values, so have dropped this. You can even drop the ID column, because that's only just the number of columns, just giving the number to the row, so it is not helping to predict the sale price, so you can drop that even. After dropping the necessary columns, you can still construct your data by removing outliers. So outliers are the values which are not according to the trend. After pre-processing and everything, you have to train your data using an algorithm. For doing that, you have to split the data, and we have split the data in 70 to 30 ratio with fixed values. So every time it does not take random values, it's just every time it takes the same fixed values. uh, mm, uh, so to train, we have used two algorithms: linear regression and random forest. So linear regression algorithm helps to tell about the relationship between two variables. One is dependent and one is explanatory variable. It tries to fit the data set in a single line, and that the equation of that is y is equals to mx plus c. So random forest is just an ensemble learning method for classification and regression, and it takes the help of multiple decision trees, and there's a voting system, and which has a higher votes, that feature is taken. So um, uh, to validate this, we have taken some errors. So that are mean absolute error, mean square error, root mean square error. Mean absolute error is just the difference between the actual and predicted values. Mean square error is actually the average of the square of the difference between the original and predicted values. Root mean square error is the root of mean square error. To see the performance of an algorithm, we have used R2 squared score. sorry, R2 score. So R2 score is also known as coefficient of determination. So we can see, you can see that in our model, the R2 score is actually the same for both random forest and linear regression. It is 87. So the it is in the terms of percentage. Actually, the R2 score lies between 0 and 1. But I have multiplied into 100 to express it in terms of percentage. So yeah, so R2 square should be, if a model has R2 square less than 0.7, then it is considered to be a bad model. If it is considered, if it has R2 square, R2 score, sorry, R2 score greater than 0.7, then it is said to be the best model or good model. So we have got R2 score of more of about 87% or 0.87. So it's a good model. But to compare this, we have to also consider root mean square error. And root mean square error for random forest is very large, that is 2395, where for linear regression is just only 135. So from this we can conclude that linear regression is better than random forest for this particular model. So these are the references which I have referred. Thank you.